Now we're going to talk about a subject very dear to my hardware hacking heart, apparently microcontroller programming Zen, or advanced microcontroller programming for those of us who love AVR chips. And with us is wesen. At the end, we'll have about 10 minutes for questions. So you should either come find me or go to the mic near the AV guy. And wesen, if you could please repeat the question, then
sure.
The camera will pick it up. Thanks a lot. And will everyone please give him an excellent welcome.
All right, thanks. My name is Manuel, or wesen, and I've been building software for microcontrollers for a few years now, and started doing it like pretty intensively for the last year. I held a talk last year at the Congress about devices and building MIDI controllers, doing music with them, and I've basically spent the whole year programming firmwares for not exactly this CPU, but this kind of CPUs. So I wanted to ask, who is doing microcontroller programming here? That's pretty nice. Who has been using the AVR microcontroller? All right. And who has been using C++ on the AVR? Okay. Yeah, basically, I call this talk hardcore microcontroller programming. I think in the description of the talk, of the first description, because my goal was to show like a lot of incredibly complicated hardware details and programming details that I discovered during this whole year. I basically revised the setup a bit, that I'm going to be like more general, not go into too much detail, because basically the whole framework is open source, and you can find all the information on our website at wesen.com. You can find me on Twitter as well. If you have questions, you can send me an email later on. So what I've been building in this company, I started about 1.5 years ago, is MIDI controllers that look like this. And the concept behind those controllers is that basically the whole hardware and software is open source, and you can program your own patches. And it wasn't this way at first, but for the Congress last year, I prepared some workshop environment about programming, started using code sketches like on the Arduino for this device, and this is basically where the whole framework I'm going to talk about stems from. So basically this device is connected to a synthesizer or to multiple synthesizers using MIDI ports on the other side, and you can use the knobs and buttons to trigger effects or do some crazy stuff. The device inside, the CPU inside this one is a xmega 64 microcontroller, so it's basically an 8-bit microcontroller with 4 kilobytes of RAM and 64 kilobytes of flash. I added some additional RAM because 4 kilobytes really is too limited. And basically built what I call the MIDI Arduino framework, which is this huge framework used to control the whole GUI thing, so that basically you can build pages like Windows. You have directly an event system for the whole GUI, like if you press a button, you'll receive an event. There's some MIDI parsers, there's some code to interface with specific synthesizers, all kind of stuff. So it's basically 30,000 lines of C++ now. Some parts are in assembler, some parts are in C. But basically it's become this huge object-oriented framework. And you can all find it on GitHub. I think I have the URL on the last slide. So if you want to check it out and use it. And what I'm going to talk about basically is when I started to build this whole thing, I started like using the techniques I knew from traditional software development, Agile programming, which is kind of this buzzword, which means that code has to be flexible and the way you interact with it is flexible as well. And it's not a view that is very common in the embedded industry, because you basically build this one firmware and flash it into the device, and it's never going to change anyway. So you don't have code as flexible as on a normal device. And then you have these huge restrictions that you have like just a few kilobytes of RAM, which make it much more complicated in a way to do refactoring, to do unit testing, for example. But I started to think like if you're clever, if you build some scripts, if you just like bring over this mindset to embedded, you're gonna find some pretty nice stuff. So basically, this first part of the talk is going to be about agile techniques applied to embedded programming. The second part is going to be about using C++ in an embedded framework, what kind of things do work on an AVR, which don't work, what you have to be careful about. And the third part is going to be about optimization, which is a huge task, actually. It's basically part of everything you do on embedded programming is optimizing code size, optimizing speed. And then I'm going to go into a bit more technical details about timing, latency, and real-time requirements, which are especially interesting when you're building musical instruments. And the final part is going to be about debugging techniques, like what kind of stuff do you use when you debug that kind of environment. The whole idea behind the microcontroller is I started using CNC as well, so this kind of all goes together. It's rapid prototyping of devices and of firmwares. So you have this MIDI controller and you want to try out a few ideas, and if you start to use like all kind of development techniques for it, you're just going to spend like 2 days building make files, building like harnesses and stuff like this, and that was basically too long for me. So last year I built this, I used the Arduino editor, replaced the whole libraries, the whole code, for it to work with my device. Now I can just like write a few lines, say if you press this button it's going to send a note, if you press this one it's going to reverse the sequence, for example, and then just try out very quickly the whole way to approach this. I can use that for GUIs, but for devices as well, like having scripts that take an Eagle file, just like build a device, build a whole casing as well. You just like have to put it on the mill and it's going to generate the device. So actually, I'm saying like things in a sentence, and it's a huge amount of work behind it, which you can check out from the Git repository. For example, this whole software that generates the CNC files is like a few thousand lines long, and it's very interesting. But I'm just going to skip the whole hairy detail thing. I think you all know the Arduino platform. I kind of use the same idea that you just have like this one connection to the PC, which in my case is MIDI or MIDI USB. And you use that as a bootloader, but also to interact with the device. So you plug in the MIDI controller over MIDI, and the bootloader actually understands MIDI, so I don't have to replug cables every time trying out something, and just have this whole kind of test setup. And then don't need a program, I don't need anything, I just have this normal environment. And it's actually, that made the biggest difference, I think, in the whole way I approach this development, is that you can, if you want to upload a test suite, for example, you just have to press one button and it checks the test suite, sends the results over MIDI. I have a profiler that works over MIDI, so it sends me like profile information while it's running, and I can interpret it at the other side. Some pretty interesting software we have as well is a patch manager, which is kind of an app store where users can click different firmwares for the device and just like press upload, and they have like this description of the firmware. I can actually show that, which looks like this. So you have basically this software. You can click on the different firmwares. You can read the documentation for it, and then just press upload. It's going to show the MIDI ports, and you can upload the new firmware. So all kind of ideas that stem from this sketching Arduino platform idea. I didn't actually use any kind of Arduino code or Arduino stuff in there. Another very important part of the whole Agile development is using source control, which funnily is not that common in embedded development either. Like you have the few projects I worked on, you had like all these test 1, test 2, test 3 directories for the source code, but it's actually pretty crucial if you want to have good firmware support. So I basically check in the whole source code for a special revision of the firmware I ship to customers, and then I can go back and have exactly the kind of same setup, have the same RAM problems, for example. And one pretty important point of the whole thing is to check in the toolchain as well. Like when the toolchain changes, you're going to have different assembler code, and due to the restricted resources, you're going to have a lot of problems if, for example, a multiplication takes one cycle more in this one case and in the other case. With Git, which I discovered this year, it's very easy to do branching, merging. If you try out a new feature, do your refactoring in a branch, and then take it back to the main branch or not, depending on the case. And